Hello friends, welcome to the Introduction to Docker video tutorial. My name is Parvez and I am the DevOps expert and the host of your video tutorial today. In this video, we are going to talk about what is Docker, what is the difference between a container and a virtual machine. We will see the various terminologies in Docker like Docker engine, images, containers, registry, repository, Docker Hub, and certain Docker orchestration tools. Once we are done with that, we'll have a good idea of what is Docker and what is various components, and then we will see the glimpse of images, and then we'll get started with the containers. So at the end of all these topics, you will be very comfortable to actually dive in and do some hands-on and get into the details of all these areas as far as Docker is concerned. So what is Docker? Docker is an open source platform for building, shipping, and running the application using container virtualization technology. So as you can see, it's an open source platform and it has three things: building, shipping, and running. So you can build your application, you can with all the configurations that you require, you can ship it to wherever you want, and you can run it in whichever environment you want. It uses a technology called virtualization, but there's a slight difference. It's not the normal virtualization, not the normal virtual machines, but it's a container that we are talking about. So the technology is container virtualization technology. Docker itself consists of various tools and products, which are like Docker Engine, Docker Hub, Docker Machine, Docker Swarm, and Docker Compose. And Kitematic is the UI client for Docker. Now, if I talk of the dark ages, let's talk about and get some idea of what is a virtual machine and the container and what is the difference between that. So if I talk about the dark ages, I mean the ages when we started developing the application, you had one physical server and your applications were deployed on those servers. So for each application, you needed the physical server which had its own operating system and all the entities that are required for to run. Now, if you have another application, you had to have another physical server, another physical machine, and deploy the application there. So in one physical machine, you are able to deploy only one application. Obviously, it had many disadvantages like slow deployment times. So if you have another application or another version of the application and you go to your IT team saying that I need to deploy this, they say we don't have the servers available. So you actually go and you have to buy the server, and by the time you get the server, it's a long time. Obviously, there are huge costs and wasted resources because just for the application to run, you need to have the complete setup of physical machine. It was difficult to scale, obviously, as I said, because the more number of application, the more number of physical machine you need, which is again a huge cost. If you don't have the machine, you have to get the machine physically, so it has its own time, so it's very difficult to scale and migrate. And there was a vendor lock-in. So if you are using Red Hat Linux operating system, you have OEM equipment that were provided by Linux machines, and you had to buy only those. To solve this problem, there came an hypervisor-based virtualization. This means that you had one physical server, one physical machine, on top of which you can create various virtual machines. So as you can see in the diagram, you had this one physical server with the host operating system. So host and the guest means, you all know, host means the operating system of the one physical machine, and guest is the VM guest. Okay, so there was a layer of hypervisor on top of the host operating system, and that helped you to manage the virtual machines. Each virtual machine has its own guest operating system on top of which you deploy the application. Now there are certain advantages, various advantages. One is you had better resource pooling. You were able to share the resources from a physical machine. One physical machine is divided into number of VMs, and you are able to share the memory, the hard disk for of that. It was easier to scale. Yes, so if I want now two virtual machines on the same hard disk, I can create one more machine and do it. And with the advent of the cloud, with the adventure of the cloud operating system, the rapid elasticity and the pay-as-you-go model, it was easier to create virtual machines on the cloud. But with the benefits, there were limitations. Each VM still required CPU allocation. So if you in a physical machine, if you have 8 core CPU, you still, when you're creating a virtual machine, you had to allocate a CPU. Storage you need, hard disk, RAM, memory you need, and an entire guest operating system is what you need for a virtual machine to come to an existence. The more virtual machines you run, the more resources you need. It was intensive. It used to take a lot of resources of your host operating system. Guest OS means wasted resources because it was an operating system over an operating system that you would install. It was wasting all the resources. And still application portability wasn't guaranteed, because if you set up a VM here and run, and then on some other environment there could be some other version. For example, if you set up a VM here with Python version 1.5 and it goes to the staging area or the client area, and their Python version is 2.0, your system might break.